friends, myself Kapil Bavisiya from Marwadi University. Today I am explaining a video about one of the specific communication technique, DSSS Direct Sequence Spread Spectrum. First of all, let's see what is spread spectrum. Spread spectrum is a communication technique that spreads a narrowband communication signal over a wide range of frequencies for transmission, then dissipates it into the original data bandwidth at the receive. These are four major cases in which spread spectrum is commonly used in radio communication. Interference. Real example is two people talking at the same time when one person is talking to another person too loudly with intention to disturb the communication. Another one is jammer. The goal of jammer is to disturb the communication of his adversary. The jammer has a priori knowledge of most system parameters. Multipath distortion in wireless communication system. There exists multipath propagation. Multipath means tell more than one path from transmitter to receiver. Such multipath may be due to reflection from ground building or other object like trees, etc. Fading. Multipath may result in fluctuation in received signal amplitude. Variation of signal level due to the multipath propagation is known as fading. Secure communication. Ordinary radio transmission easy to intercept by unwanted listeners. There is two main types of spread spectrum. First one is a frequency hopping spread spectrum FHSS and second one is direct sequence spread spectrum. Now we are going to learn a DSSS. It is modulation technique and it also known as direct sequence code division multiple access. The name spread spectrum comes from the fact that the carrier signals occur over the full bandwidth of a device's transmitting frequency. Now let's take the block diagram of DSSS. It is shown in the slide. In spread spectrum, input data signal is modulated 2 times. Here, transmitting section of DSSS communication system already modulated signal is given as a input to XOR gate. So this is type of second modulation. The PN sequence is combined with already modulated signal. For example, BPSK signal, and then output is fetched into the transmitting antenna. Here the transmitting antenna and free space antenna is visited to transmitter to receive radio signal. More that the effective modulation increases the bandwidth of the signal. Here narrow band signal is converted to wideband signal by combining with PN sequence is also called a shipping code, and the reverse process takes place at the receiving end of communication system. So antenna is an interface between the transmitter and the free space. Receiving antenna is visited to receive radio signals. Here the second time modulated signal is a wideband. Now let's see advantages of DSSS signal. It reduces frequency selective fading, and advantages of DSSS in cellular networks are given below. Base frequency can use the same frequency range and several base stations can detect and recover the signals. Now see the example. Let's take one DSSS waveform. In transmitter part, this is the input data of 8-bit bit stream. Bit 0 contain bit stream of 0, 1, 1, 0, and bit 1 is contain bit stream 1, 0, 0, 1. It is a bit stream of zeros complement. And next, the locally generated chip code of 32-bit stream. We will XOR both waveform. XOR of same inputs are 0 and XOR of different inputs are 1. So we will get output waveform in the form of the XOR of input A and chip code C equal to A XOR B. In the receiver part, now we have two waveform. First one is XOR waveform of A and B, and the second one is locally generated PN bit stream identical to B above. Now we will XOR this both waveforms, so we will get output waveform in form of the main data input signal. If this encoded signal is stolen somewhere in transmission and it is been tried to decode using some other chip code, the original signal will never get constructed again. So DSSS provides us great security. Thank you.